Alright, this is video 4, continuing in our practice test solutions. So a vector has an initial point at point P, P and a terminal point at Q given by these coordinates. Find the vector V. So the displacement vector, position vector, is delta x, delta y. So that is, final point is Q. So that's y2 and x2. So it's 1 minus 7 for the x component, and then 9 minus 8 for the y. So 1 for the y and negative 6 for x. So negative 6, 1. You might see that written as negative 6i plus 1j also. Could be written that way. This way they're wanting this time. Next question. Find the magnitude of negative 5, 1. Pythagorean theorem. That's negative 5 square plus 1 square root. That's 25 plus 1 is 26. So it's the square root of 26. Next question. Okay, now we're given a vector in magnitude and direction form. Okay, it's in norm. We're given the norm of the vector is 18, its magnitude, and the angle it makes with the positive x-axis is 150 degrees. So it looks like if this is the x-axis, the vector is right here, 150 degrees, which leaves 30 degrees here. We want to resolve that into components. Okay, and this is 18, so pretty easy. This is, if you call this r and this theta, it's r cosine theta, comma r sine theta, which is 18 cosine 150 degrees and 18 sine 150 degrees. Notice that in this quadrant, x is going to be negative, y is going to be positive. And with this a reference angle of 30 degrees there, okay, then you could label this, well, whatever length the longest side is, which is 18. Let me get this so we can see it a little bit better. If this is 18, then the shortest side is half of that, so that makes this 9. And this, the longer leg then is the shortest side times the square root of 3. 9 square root of 3. So cosine is 9 square root of 3 over 18, negative. And the sine is positive, 9 over 18. Okay, and then we still got to multiply that by 18 here and here. Well, actually, what am I doing? The cosine is square root of 3 over 2. We already have it worked out, basically. I already have the components done. The components are negative 9 square root of 3 and 9. Okay, you might see that written this way. Here. You could also see it written as negative 9 square root of 3i plus 9j. And they wanted it in that way. Next question. Magnitude and direction, 40. Theta is 5 pi over 3. Again, find I and j components. So the vector in ij components is, again, 40. Magnitude of v is 40, and times the cosine of 5 pi over 3, 40 sine of 5 pi over 3. So again, 5 pi over 3 is where? 5 pi over 3. That's a full pi and another two-thirds of a pi. That's going to be over here. That's just pi over 3 short of a full circle rotation, of a full 2 pi. So that's 2 pi minus 1/3. So this angle is pi over 3. So if I just do this, and let's say I don't pay attention to if I make this radius 2, this is square root of 3, this is 1. Now the actual vector is considerably longer than that. It goes off the screen here because it's 40 times that. But I can get the cosine off of this. The cosine is 1/2. And the sine is square root of 3 over 2. Multiply out, you get 20, and then 20 square root of 3. And where in the quadrant we're in, sine is negative, cosine is positive. So this one's actually a negative here. So like that. And of course you might see that written as 20i minus 20 square root of 3j, which is how they've done it here. Okay, so u is 5, negative 1. V is negative 3, 3, and we want the dot product. Dot product is pretty easy. So u dot v, 5, negative 1, dot, negative 3, 3. All we do is we take the 5 times the negative 3 to get negative 15. We take the negative 1 times, we do it kind of like this. Negative 1 times the 3 is negative 3, and add those together, and we get negative 18, and it is a scalar. Find the angle between the two. Okay, so we know that the dot product is the norm of u times the norm of v times the cosine of the angle in between. So if we solve for the angle in between, the angle in between is the inverse cosine of, so we're going to take the dot product, divide by the two norms. That'll give you the cosine of the angle, then do an inverse cosine. So inverse cosine of, well, we know the two, I'm sorry, this one we're not trying to find the, that's it if we were trying to find the angle. This one we're given the angle. We just use this formula straight away like it is. So you want to memorize this formula. So just plug in. Plug in the 3 blanks. Norm of u is 2, norm of v is 4, and this is 75 degrees. And we're going to round this off. So that's 2 times 4 times cosine of 75. I am in degree mode. That's good. So about 2.07055, etc. They want to round it to the 10th, so 2.1. Next question. Complete the sentence. Use the substitutions x equal r cosine theta and y equals r sine of theta to form a rectangular equation into a polar equation for the same curve. So, know those basic conversions there. Okay, so it looks like we're into some polar graphing now. Number 26. Graph the ordered pair 3, 45 degrees. So, well, they don't have a scale on here, so we have to. I'm going to assume that each one of these circles is 1. If that's the case, then this circle here is 3, so it should be on that circle, and all of them are on a circle of radius 3. So they all have the 3 right, but we want to be at 45 degrees. So these are, that's 30 and 60 degrees, so we're halfway in between here. It's going to have to be A. Now which is not equivalent to it? Okay, so let's look at these here. So if we go negative 135, okay, let's see, negative 135 will get you to the same place. 90, 180, 270, and 45 more is negative 135 degrees, and you go out a distance of 3, and you're at the same point. So that's the same. 3, 405 degrees. Okay, 405. So there's 360 plus 45 is 405. So that would be rotating around that way. So that's a coterminal angle, still a distance of 3. 225 degrees. Okay, let's look at the picture here. 225 would be actually to here. But instead of going this way, you go the opposite way, 3. And guess what? We end up with the same place. 3 225 would be down here. That would be in the third quadrant. So that's the only one that's not right. So C would match D. And that's not the same as A, which matches A, B, and C over here. Find the rectangular coordinates and the polar coordinates. So you're given r theta is 6 150 degrees. We just use x equals r cosine of theta, which is 6 times cosine of 150 degrees, and y is r sine of theta. That's 6 times sine of 150 degrees. Let's go ahead and graph it here real fast. So 150 degrees is here, roughly, leaving 30 degrees here. We're going to go out a distance of 6, so that's 6, and I know I can plug in this formula, but I also know from this is a 30 degree reference angle, so this number is half of that one, so that's 2, and this is 2 square root of 3. So the x is negative 2 square root of 3, and the y is positive 2. So xy is negative 2 root 3, and y is 2. Negative, half. Half of 6 is 3, excuse me. Yep. 3 root 3 and 3. Negative 3 root 3 and 3. Correct. Okay, next. What do we have here? Rectangular coordinates of the point are given. Find the polar coordinates. And we're going to choose a positive r and a theta between 0 and 2 pi, and that makes us have a unique answer. So here we're graphing it here. We go to the right 4, okay, and we go down 4 times the square root of 3, wherever that is, somewhere down here. Something like this. Okay, so we're given it with x and y components, so we want to find this theta. Actually, they want to find it between 0 and 2 pi, so we actually want to find that theta. And we know this one is 4. This is 4 times the square root of 3, so this one's 8. And this, we know this is our special angle, with this being the 60 degrees, or pi over 3 radians. Well, actually negative, because we're going this way. But what we want to do is the positive direction. So it's 2 pi minus that, so that's 6 pi over 3 minus, so it's 5 pi over 3 would be the angle. So 8 comma 5 pi over 3. Almost done. X squared plus y squared equals 4. X squared plus y squared is r squared. So r squared is 4. So r is plus or minus 2, but we might as well, if you just say r is 2, that covers everything. So it's just a circle of radius 2 centered at the origin. R is 16 sine of theta. Okay. And we can do this a couple of ways. One thing is we can put it in polar mode and actually just graph it on here. That might be helpful to see it. We can also, though, change it to polar coordinates. Let's multiply both sides by r. And notice this little trick is helpful because r sine theta is just y. And r squared then becomes x squared plus y squared. Okay. Now, now what we're doing here is we're get 0 over here and get x squared plus y squared minus 16y. And what we're going to do now is we're going to complete the square on this part right here. So we're going to factor that. So take half of this, negative 8, negative half of that coefficient, and square it. Look what you get. You get y squared minus 16y plus 64. That's okay if I add 64 to the other side. I get the same thing. So I think one of those is probably one they have. Yeah, that's A. Okay. R equals 9 sine of 2 theta. Which one is it? It's going to be a rose with that's an even number. That's going to be a rose with 4 petals. Should be C. But if you don't know that, go down here and put it in parametric coordinates like this. Go to y equals. No, not parametric. Excuse me. Polar coordinates. Try again. Polar coordinates. So polar graphing. There you go. R is 9 sine of 2 theta. For graphing we need to be in radian mode. So I need to go down. I should have put it in radian mode while I was changing it to polar. And now let me just do a zoom standard. And there we go. And actually I probably should choose to since they give us a window here, we should probably use that. The x is negative 12 to 12, and the y goes from negative 12 to 12 with an x and y scale of 2. And 0 to 2 pi will be good here, which is what we have here. So notice that is 2 pi. And just, something small, 0.1 is good. And graph that. Whoops. Did I have a 0 in there? Oh, negative 12. It just didn't come out. The 2 didn't take for some reason. Alright, there we go. Anyway, that's either way you go, that's C. Okay. Alright, now we're going to some complex numbers. Okay. 7 plus 6i plus 5 minus I. Just so that's 7 plus 5 for the real part, 6 minus 1 for the imaginary part. So that's just 12 plus 5i. Of course, actually, your calculator will do this. If you put it in mode, you put it in, let's go down here and put it in A plus BI mode, like that. Okay. Then it will just add these things just like normal. So you can do 7 plus 6, and the I, okay, where is the I? You got an I on here somewhere. It's not the capital letter I. Should be imaginary I somewhere. Oh, come on, where is it? Is this it right here? Can't see. Yeah, that's it. Second, and then the decimal is I. Okay, 7 plus 6i plus 5 minus I. And it'll go ahead and add it for you. So, not that you need that, but it will. And it will also multiply for you too, although I'm going to go ahead and multiply them out. 2 plus 5i times 4 plus I, you just do FOIL. That's 8 plus 2i plus 20i plus 5i squared. 5i squared is minus 5, so this is 8 minus 5. This is 2 plus 20i. So it's 3 plus 22i. But again, the calculator will actually do this. 2 plus 5i, and then implied times here, 4 plus I. It will actually work that out. So that's an easy giveaway question, really. And 7 plus 4i over 4 plus I, multiply top and bottom by the conjugate here, 4 minus I. This is how you work this out by hand. So the bottom you get 4 square minus I square, okay, in the bottom. So that's 16 minus a negative 1, which is plus 1. So we're down to just 17 in the denominator. In the top we do FOIL, 28 minus 7i plus 16i minus 4i square. Okay, 16i minus 7i is plus 9i. This I squared becomes negative 1, so it becomes 28 plus 4 is 32. And then finally you distribute the 17, so it's 32 over 17 plus 9 over 17i. Again, the calculator will actually do all this for you. 7 plus 4i divided by 4 plus I. It'll give it as a decimal, but then you can go to math, change to fraction, and there you go, 32 over 17 plus 19 over 17i. Real easy calculator question, actually. I to the 25th, you just take 25 divided by 4, 6, remainder 1, so this is I to the 1, remainder, whatever that remainder power is, goes up here, and I to the first is just I. Again, this is going to actually work, I think. I to the power 25. Alright, it actually is a round off problem here. This came out to be negative 0.2, 3, 4, 5, 6, 7, 9, 10, 11, 12, zeros of 5 plus I. Well, that's approximately 0. In reality, it's actually 0. So actually, the calculator lied to you there. It actually should truly be just I. But you know when you get an I to a power, it has to be either 1, negative 1, I, or negative I. Those are only 4 possibilities. Write it in polar form. 2 square root of 3 plus 2i. Okay, so basically we just got an x and y. We want to find an r and a theta. Our r is, and we can write it in the form r e to the I theta, which is another way of saying r cosine theta plus I times plus r times sine of theta, or the way they've got it, r cosine theta plus I sine theta. They've written it out this way. But either way, we just got to find r and theta. So the first blank's going to be r, and it's the square root of 2 square root of 3 square plus 2 square. Alright, let's see what we get here. 2 square is 4. 2 square root of 3 square. 2 times 2 is 4. Square root of 3 times square root of 3 is 3. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. So it's 4. Okay. And what do we get? So we know, well, this should start looking familiar to us here. Let's say 2 square root of 3 and 2. So if we were to graph this, we go up 2, and we go to the right, 2 times the square root of 3, wherever that is, somewhere in here, maybe. So this is 2 square root of 3, this is 2, so that point is 2 square root of 3 plus 2i. Well, what angle is this? Well, this side is square root of 3 times that side. This side is twice the shorter side. That makes that 30 degrees. So, there you go. But we would know that the angle in general would be, the cosine of the angle would be the real part over the length, which is square root of 3 over 2, and we want to find theta is the inverse cosine of that. And that will work if y is positive. If y is negative, we take the opposite of that. So in this case, this works, and that is, in fact, 30 degrees when we do it in degrees. Write it in rectangular form. 12 cosine of 60 degrees plus I times sine of 60 degrees. Okay, well, just work it out. Let's see. This is one of our special triangles we've been working with all semester. 60 degrees. Let's just use this in 1, 2, square root 3. Cosine of this is 1/2. Sine is square root of 3 over 2. Distribute the 12. So this is 6 plus 6 square root of 3 I. Okay, next question. By the way, you could have probably done that in your calculator. 5, previous question. Excuse me. 12, parentheses, cosine, 60. We're in radian mode, so let me be sure and put the degree symbol. 60 degrees plus I times sine of 60 degrees and we get that. What we don't see is we get this part here. It's not an exact value, but it's a decimal version. But we can check it. 6 times the square root of 3, and see that that's the 10.39 something. So we can use that to check. Okay, we want to find the product of z and w. So z is 2 cosine of 130 degrees plus I sine of 130 degrees. In other words, the way I prefer to write it is 2e to the I times 130 degrees. That's z. W is 5 cosine of 300 degrees plus I sine of 300 degrees. In other words, that's 5, parentheses, that's 5e to the I times 300 degrees. So when we do w times z, we're doing 2e to the I 130 degrees times 5e to the I 300 degrees. And it works just like it looks like it would. We multiply the 2 and 5 to get 10, and we add the two angles to get 430. Wait a minute. 130. This is 130 and 300. Yeah, 430. Okay, so that's the product, which means in this form 10 and then we get there it is at 430. Now there are other ways to do this. It looks like they're wanting, I don't know if this will take other angles or not, but it looks like what they're wanting on this problem is they're wanting an angle between 0 and 360. So if we subtract 360 from that, we get 70 degrees. So this is the same thing as 10e to the I times 70 degrees. So it looks like what they'd rather have is an angle between 0 and 360 degrees. So we'll use that version. We do the quotient, and we're just going to subtract the angles and divide the other parts. So let's see, we want z over w, so z is the one on top. 2e to the I 130 degrees over 5e to the I 300 degrees. So this is 2/5 e to the I, subtract exponents. Okay, 130 minus 300 degrees is negative 170 degrees. Okay, right, 2, 3, yeah, negative 170 degrees. But we want to add, so if we take negative 170 degrees and add 360 to that, we'll get something between 0 and 360. And I believe that's 190 degrees. Let's check out 2, yeah. So we could write that as 190 degrees there, which is 2/5 cosine 190 degrees plus I sine of 190 degrees. Okay, now we do 1 plus I to the 8th power. Okay, let's think of it in polar form. 1 plus I, if we graph it, is at this point 1, 1 on the graph. Okay, so this is 1 and 1, so this is square root of 2, and the angle is pi over 4, 45 degrees. So we could write this, it's all to the 8th power, but in polar form, it's square root of 2 times e to the I pi over 4. So when we raise it to the 8th power, this is 2 to the 1/2. It's 2 to the 1/2 to the 8th. And this is e to the I, and we multiply the 8 times the pi over 4. Okay, let's simplify. Pi over, the 8 and the pi and the 4 cancel, so this is 2 pi. And then this is 2 to the 1/2 of 8 is 4. So this is 2 to the 4th. This is the same thing as e to the 0, which is 1. So this is just 2 to the 4th, which is just 16. But again, guess what? Your calculator will do it. 1 plus I to the power 8, 16. And I believe we've reached the end of the practice test. Keep studying the practice test, and go over these videos as many times as you need. You can take the practice test up to 3 times. So keep working on that practice test, and go back and review it. Take it once, review it, go back over the parts of this video that gave you problems if you need to, and redo it again, and hopefully get your score up to 100% or very close. And then that should prepare you very well for the test. The test will be considerably shorter than this, but some of the same kinds of problems that you saw here. All right, good luck.